Hi folks, so today what I wanted to do was have a look at some application problems involving polynomial functions. Um, these questions are really limited to your ability to fluently apply what you've learnt about dividing cubics and factorising and drawing graphs. So if you're not really strong with those skills yet, it's probably important for you to go back and practice using them. But for application questions as well, what you're going to need to do is to be able to interpret what's going on in the problem and make decisions about when you apply each of those skills of graphing, solving, and factorising, etc. So I'm going to run through some examples and hopefully give you some hints along the way. The first question, this is straight from your textbook. It is about a square sheet of cardboard. It has edges of length 20 centimetres. 4 equal squares of length x centimetres are cut out of the corners and the sides are turned up to form an open rectangular box. Part A, find the length of each edge of the base of the box in terms of x. Part B, find the volume v centimetres cube of the box in terms of x. Part C, find the volume of the box when x equals 5. And part D, find the values of x for which the volume is 500 centimetres cubed. So as I mentioned in our lesson, it's really important that we read and reread the question. So on my second reading now, I'm going to highlight some of the key terms that we need to know in order to be able to do this problem. So the first thing that I come across here is that it's a square sheet of cardboard. So that's important because it's telling us, well, the length is equal to the width. So let's not forget those simple things about a square. And we know that the length of the edges is 20 centimetres. We also have that 4 equal squares, so 4 equal squares of length x are cut out of the corners and turned up to form an open rectangular box. So an open rectangular box means it just doesn't have a lid. Now before I even start really working on part A, for me, I like to draw a diagram. Now I've got a diagram in the picture here, but it's two-dimensional, and it's talking about a rectangular box. So a rectangular box is a three-dimensional shape. So before I even start, I really want to to help me visualize, I want to draw a rectangular box. And I'm going to make it three-dimensional. So here's my box. Really simple. And I can sort of visualize what's going on here. Now the other thing I know is, well, this side length here, the height of my box when I fold up those sides, it's going to have a height of x. And then the whole length of the square cardboard was 20 centimetres. So if I want just that bit there, or just that bit there, it would be 20 centimetres, take away an x on this side and an x on this side, so an x on the left and an x on the right. So that's the same as 20 centimetres take away 2 x's. And because it's a square, I use that information that it's a square to tell me, well, this side here, it has to be exactly the same as well. Cool, so I've got my three-dimensional diagram. Now let's have a little bit more of a look at the questions. Find the length of each edge of the base of the box in terms of x. Well, the first thing I'm going to highlight there is in terms of x. So that means that everything that I write down is going to have x as a variable. So we're going to create expressions or equations that have x as a variable. And in this problem, just by visualizing the problem as a 3D diagram, I've answered this already. So my answers to A is straight up that the height is equal to x. So I've got the height in terms of x. And the length is equal to the width because it's a square. And that is equal to 20 minus 2x. Okay, so I have the length of each edge of the box in terms of x. Perfect. Now we need to move on to the next part. So part B, find the volume, centimetres cubed, of the box in terms of x. So I want the volume of the box in terms of x. Now I've highlighted the volume in the box because I need to use my knowledge that a rectangular prism, the box, has a volume that is equal to the length times the width times the height. So I use the volume of a box and my formula about rectangular prisms and come up with this first initial formula. And then the second part in terms of x, all I have to do is now substitute in my answers to part A, which have the x variable. So the length is 20 minus 2x, the width is 20 minus 2x, and the height is just x. There's my equation. If you wanted, I could expand this. I'm not going to expand it at the moment. Don't really want to. It seems too hard, and I've already got an equation in terms of x, so I can stop there. Okay, part C. Find the volume of the box when x equals 5. Alright, so they haven't used the word substitution here, but they are telling me that they want me to work out what v is when I know that the x value is 5. So you need to interpret what it's actually asking you to find is as simple as substitute in x equals 5 into this equation. And always important to show your workings, so I'm going to put the volume 20 minus 2 times 5 times 20 minus 2 times 5 times 5, which gives me 10 times 10 times 5, which equals 500. Perfect. Okay, finally, we have the question part D. Find the values of x for which the volume is 500 centimetres cubed. Now we've actually just done one problem where we know that it's 500 centimetres cubed right there. But read the question carefully. Cannot stress this enough. That word values has an S on it, so that means there's more than one. So they're giving you a hint, whether you realise it or not, that I need to do this in a little bit more depth. So my next step now is I want to find out when the volume equals 500. So I can do this two ways. Number one, I can make my equation equal 500. And I need to solve that equation to find x. Now most of you will want to jump straight to your calculator, and the examples in the book use your calculator as well. So I'm going to actually go straight to my calculator at this point in time. But if I wasn't going to use the calculator, what I would need to do, so I'll actually write this down. Without a calculator, you would need to expand the brackets and then you would need to rearrange the equation to get it equal to 0. And then once our equation's equal to 0, we can factorise and use the null factor law to solve. In an exam or a test, if they want you to do this by hand, they will kind of break down the question and into multiple marks. And essentially, if there's multiple marks for this question, they want you to do it by hand and show all of your steps along the way. If there's a single mark and it's just 1 mark question, then it's perfectly fine to jump straight to your calculator. So hopefully on my iPad, I'm going to get my calculator out, and I've just got to find my calculator on here. Now remember, we've spoken about this before, the calculator on the iPad looks a little bit different to what you've seen before, but the functions are all essentially the same. So I need my tools. It is an algebra function to solve, and I have my equation, which is 20 minus 2x times 20 minus 2x times x, and we want that equation to be equal to 500, and we need to find out what x is. So there's my calculator equation. We've got these complex expressions. Now the book doesn't ask for a decimal place, so you would normally put this in as an exact value, and you would type in exactly x equals -5 bracket root 5 minus 3 over 2, and then +5 bracket root 5 plus 3 over 2, and x equals 5. To help you visualize, I'm going to change them to decimals. So if x equals 1.91, or if x equals 5, or if x equals 13.09, then I would have my solutions. So let's go back to my question. For this, it is, oh, my pencil's not working all of a sudden, so let me just get that to kick back in. For this problem, if x equals 5 or 13.09 or 1.91, then I would have my solutions to this equation. And again, if you need to try and visualize what's going on beyond the 2-dimensional diagram and the 3-dimensional box, I could do things like use the calculator to graph it. So I've got to remember how to get to my graphing page here. Let's just go home, add a graph. So if I get my equation 20 minus 2x, I'm going to cheat this time. I'm going to use squared next to that because we had 2 of them. Then I'm going to times it by x. If I draw that graph, pretty much can't see it. That's because I need to zoom in on this graph. Now we had at least 500, so I'm going to go to 1,000 there, and we can see the graph. And then I haven't gone far enough to the right. I need to go to at least 20 on the right hand side. Maybe I'll actually just drag it and zoom it. And then I can actually add the other graph where y equals 500, and I can see these 3 points where they intersect. So home, analyze graph, find the intersection point between there and there. There's one of them. I can find the intersection point between those 2 points. So that's another one. And then finally repeat that, find the intersection between those 2 points. And we get the same answers. So there's a different approach using a graph. Okay, that's probably enough for this question. Lots more we could do, but you need to start playing with them yourself.